welcome back. Today we are actually going to do question 2 from January 2019, paper 2. This question is really simple and it actually tests the first ever topic in your syllabus, which is particular theory and evidence for it. So diffusion as well as osmosis. So I'm sure this is something that you guys already know, and it's going to be a really easy question for you all to solve. So Jamila is in her room studying and smells the scent of curry coming from her mom's cooking in the kitchen area. She thinks to herself, diffusion at work. Define the term diffusion. So remember, this is all providing evidence for the particular theory or the kinetic theory. So to give you guys a little reminder, there are 4 main points for your particular theory. One of the main ideas is that all matter is made up of particles. So you can visualize them as little spheres moving around. In the different states, your particles will be arranged differently. And the second point is that all of your particles are in constant motion. Temperature affects this. So diffusion deals with the movement of particles, and that is why it supports the particular theory. The main pointers you guys should have in your definition, it is the movement of particles from a region of higher concentration. Higher concentration means we have a lot of particles together in a smaller area, to a region of lower concentration. So meaning where we have our particles spread out, we don't have a lot of particles in a smaller area. And this continues until our particles are evenly spaced. We like to call this equilibrium. So those are the 3 main things you need to have. Your particles are going from a higher concentration to a lower concentration until equilibrium has occurred. So explain how the diffusion of the scent of curry supports the particular theory of matter. So now we need to link this back to some of the main ideas for the particular theory. And it's actually going to be the 2 pointers I mentioned earlier. So remember, from our definition, diffusion is the movement of particles, which is the first main idea in your particular theory. So it's supporting that. And also, we are dealing with movement of particles, which is providing evidence for particles being in constant motion. So it's supporting 2 of the main ideas behind this theory. So we can just go ahead and link that together. So it supports that all matter is made up of particles and our particles are constantly moving. In order for Jamila to smell the curry, it means that your curry particles had to have moved from the kitchen all the way to the living room, wherever she was. So that is providing evidence for the particular theory. Osmosis would work in a similar manner. If you guys had to support the particular theory in the same way, it's going to be the same thing. It deals with the movement of particles, and it will support that all matter is made up of particles. Diffusion is a process that can also occur in liquids. State how the arrangement of particles in a liquid differs from that in a solid and gas. So we know that we have 3 states of matter: solids, liquids, and gases, right? But the arrangement of particles in each of the states of matter would be different. This is due to how much energy our particles possess. But they are only asking us to talk about the arrangement of our particles. So we are just going to give them that information in our answer. So we want to know if our particles are packed closely together or if our particles are very far apart from each other. So what can you guys tell me about the arrangement of particles in a solid? So think back, maybe we can throw in a diagram to help you guys with the different arrangements. For a solid, we are going to visualize it as our particles are very tightly packed together, but in a regular repeating arrangement. In chemistry, we call this regular arrangement a lattice. Alright, so our particles are very tightly packed. Visualize sardine in a can, kind of packed. But in a liquid now, our particles are not as close. and they are also not in a regular repeating manner. It's actually an irregular arrangement. So you can take a look at the diagram shown. In a gas now, our particles are even further away from each other, and again, they are irregularly arranged. So we are going to state this information, and this will be the answer for part 3. As they are just asking for arrangement, we are not going to talk about the kinetic energy of our particles, forces of attraction. We are just simply going to talk about how the particles are arranged for each of the states. Apart from diffusion, identify one process that supports the particular theory and state one example. There are 2 processes that support the particular theory. One is diffusion and the other is, let's see if you guys can figure that out. I gave you all a hint earlier in the question. It starts with O. The answer is osmosis, right? Osmosis is a specialized kind of diffusion. It only deals with the movement of a certain type of particle, that is water particles, right? So we are going from a region of a large amount of water particles, we call this concentrated, to where we don't have as much water particles, dilute, until it is evenly spaced. But a main difference between diffusion and osmosis, we need to have a partially permeable membrane, and there's a volume difference at the end. So the answer is osmosis. An example could be if you simply place a potato strip in water, you might notice it becoming more rigid or even longer at the end. That's probably an experiment that you guys would have performed. Another use of osmosis is actually to help deal with garden pests. So I don't know if you guys have ever seen a frog and maybe your grandmom or your mom says, okay, hurry up and bring the salt. And you see them throwing salt on the frog. It's because when you throw the salt, it actually dissolves in a slimy outer layer of the frog, creating a concentrated solution. And water is going to move from the dilute to the concentrated. It's going to come out of the cells of the frog and essentially dehydrate them until they die. So this is a practical use of osmosis that you guys can remember. You can remember placing it in water. You can use this for pawpaw as well. All these are examples of osmosis. Another example you guys can remember, it's used to preserve meat. So let's say we have jerky, you want to make jerky. You'll put salt or sugar on your meat to draw out all of the water and help to keep it for a longer period of time. Any one of these could work for this question. Alright guys, so this is actually the end of question 2, a very simple and short question, recapping particular theory. So make sure to pay attention to the 4 main ideas behind that theory, your definitions for osmosis as well as diffusion. Alright guys, thanks for joining me today. See you all next time.